Hey everyone, in this last video for section 10.2 on infinite series, we're going to take a look at what's called the nth term test for divergence. So what this test tells us is if our series will diverge based on one particular piece of information. So there are other tests that will come up in the future that we'll talk about in other sections, but for now this is the one that we're starting with, and it says the following. If the limit as n goes to infinity of our sequence, if that's not zero, or if it just doesn't exist, then our series, the series where we're adding the terms of the sequence, diverges. Okay, so quick reminder about the difference in those terminologies. Series, you're adding the terms. Sequence, it's just a list of terms. So if the limit of the sequence is not zero or doesn't exist, then the series where you're adding diverges. Okay, so I'll show you with this example. So here is a series. These terms would make up a sequence, and we're adding them. We're adding the terms from term 1 all the way to term infinity. Just keep adding the terms. So what we're going to do is we're going to say, well, does this series diverge based on this limit of its sequence? So we're going to start with the limit of the sequence. So the limit as n goes to infinity of this quantity here, which is going to be the terms of our sequence. Okay. And we've seen stuff like this before, so this limit, we can take this pretty quick. We are approaching infinity, so all we really have to do is divide top and bottom by the highest power of n from the denominator. So I'm going to divide every term by n, and then let's simplify. So this is the limit as n goes to infinity. On top, that becomes -1. First term in the bottom, that becomes just 2, and then plus 5 over n. And if we think of it plugging in infinity or something very, very large, this 5 over n, this is like 5 out of a trillion, a very, very tiny amount, that's like 0. So this limit becomes -1/2. Alright, so this is the limit of the sequence, but notice this is not 0. It does exist, this does exist, but it's not 0, and according to this nth term test, that means that this series diverges. Okay, so diverges. So let me make it make sense, the difference real quick with the sequence versus the series. So why this is true, intuitively why this might be true. So for the sequence, let's just take a few terms from the sequence. Alright, so for the sequence, we have the following. I'm just going to label a few, maybe 3 terms. Starting with n is 1. When n is 1, on top I'm going to get -1, on bottom I'm going to get 2 plus 5. So I have -1 over 7. Remember, it's a sequence that I'm talking about currently, so I'm listing, so commas in between, sequence of terms. When n is 2, -2 on top, 2 times 2 is 4, plus 5 on bottom, so -2, and then 4 plus 5, so 9 on bottom. Okay, let's do 1 or 2 more. When n is 3, -3 on top. 3 times 2 is 6, plus 5 is 11. And we'll just do one more. -4 for n, n being 4 on top. And then 4 times 2 is 8, plus 5 is 13. And we would keep going. It is an infinite sequence. So now, this sequence, if I were to plot the points, they would converge to this value of -1/2. Let's just draw that really fast. So I'm just going to plot some points of this sequence. This is my a sub n axis. Notice how small these numbers are. I'll put them in decimal just so they kind of intuitively make a little bit more sense to you. -1/7 is about, this is about -0.14. -2/9 is about, let's see, I didn't memorize it, so this is -0.22. -3/11 is about -20.27. And then this one here, -4/13 is about -0.31. Okay, so that's going to help us plot those points a little better. So I have, when n is 1, my output is about -0.14. So I'm going to just reference -1 down here. So here's -1/2. So -0.14 is like pretty small. It's like right there. A little bit further, when n was 2, I got negative 0.22, so that's a little bit lower. When n is 3, we got negative 0.27, so maybe like right there. When n is 4, a little bit lower, negative 0.31, and so on and so on. And so what's happening with this sequence of terms is they're going to keep going down, like decreasing, but they're going to eventually kind of make their way toward negative 1/2 and just approach that value. Those are supposed to be points. Okay, so they're going to approach negative 1/2. So that's for the sequence. But the difference with the series is that it's about adding those terms. So for the series, the difference is I would have to be adding those terms. So it would look like negative 1/7 plus negative 2/9 plus negative 3/11 plus negative 4/13, and so on and so on. Okay, so this part, this series we just figured out, diverges. And why does it diverge? Think about why it's going to diverge. Well, this sequence is approaching negative 1/2. If we keep going toward infinity with these terms in the sequence, think about how that affects if I were to add those terms together. If I'm getting really close to negative 1/2, let's just talk about at infinity, like way out here. If I'm getting really close to negative 1/2, then as I'm adding my terms, it's like me adding negative 1/2 and another negative 1/2 and plus a negative 1/2 plus negative 1/2. It's actually growing. That value from adding is getting larger. So it kind of makes sense why this limit would have to be 0. Well, if it's not 0, then it diverges, because if it's 0, or if it converges, it's got to go to 0. These terms can't keep changing, or when I add them, it would be growing. And so just so you get a kind of a feel for this, if I start to add these up, I'll just show you why this is, again, another reason why it's diverging. If I add up the first two terms, so my partial sum of the first two terms, if I add that up, let's see, I did this earlier and I got about negative 0.37. The third partial sum, if I add up the first 3 terms of this series, I got negative 0.64. If I add up the first 4 terms, then I got negative 0.96. Okay. This number is actually growing. So this series was going to diverge. So the difference is if I add up the terms, is it going to converge to some value, or is it going to go to infinity or negative infinity? Now, what I mentioned was that this is the opposite of this statement is not true. So be careful about that. If the limit of the sequence is not 0, the series diverges. Here's the opposite. If the limit of the sequence is 0, the series converges. That's not necessarily true. So just be very careful with the wording here. You have to take it exactly for how it's stated. Just because a limit of a sequence might be 0, it does not imply that the series converges, the opposite. So that is just something to be aware of. Alright, I'm going to show you a couple more things on some formulas that you can use with converging series, and then that's it for this section. Alright, so a few last things to show you from this section. I just wanted to mention this theorem so that you are aware, but be careful again to not think that the opposite is true. So if your series, so notice this represents a series because you're adding the terms of a sequence. If you already know that your series converges, then the sequence converges to 0. Okay, so the opposite is not true. It doesn't mean if the sequence converges to 0 that the series converges. But if you know that your series converges, then the sequence must converge to 0. Alright. Now here's more information to share with you, and this is some rules that you can use if you have convergent series. So if you have 2 convergent series and you know that the sum of one we're calling capital A, the sum of the other we're calling capital B, then you can use the following rules. And they're fairly straightforward rules. They're very much similar to the rules you've seen for limits in the past. And lastly, we have the following. If every non-zero constant multiple of a divergent series also diverges. So if you have a divergent series and then you multiply it by some value, as long as it's not 0, then that result, that other constant multiple divergent series of the one you know about, that one also diverges. And then part 2 here, if you have a converging series and then a diverging series, and then you add them, okay, or subtract them, then the result diverges. So the previous rules we just looked at, those rules apply to 2 converging series. This one is talking about if one of your series diverges and the other one converges, then when you try to add or subtract them, that result will also diverge. All right, and that's it.